Hi, I'm Atomic Tom. Welcome to the lab. The focus for today's British Science Week 2025 session is star cycles. You've probably heard of the life cycles of different living things before. Humans, frogs, sunflowers. But have you ever thought about the cycle of a star far away in space? I wonder what you already know about stars. What is a star? Where is our nearest star? Or what's it called? Do you know how a star is formed? And do stars change over time? Have a little think about that. Let's start our session by thinking about our key vocabulary for today. Have you heard these words before? Do you know what they mean? Gravity, nebula, supernova, black hole. So what is a star? Well, it's an incredibly hot, glowing ball of gas. Just like living things like humans on our planet, there's actually a bit of a cycle to a star's life. Stars are not alive in the same way that we are, but there are some similarities. They are made, they change, and eventually they end. So wherever you're watching this today, maybe you could use the Atomic Science Human Life Cycle resource and see how easy it is to sort the cards into different ages in age order, putting the youngest human at one end and the oldest human at the other end and all the others in between. Try and get them in age order. And it might be a good idea to pause the video while you do that. Now we know that babies are born after growing and developing in the womb for around 9 months. Babies need lots of help when they're first born, don't they? They can't do much for themselves except sleep and cry and feed and wee and poo. Babies then grow into toddlers and then children who go to school or learn different things about the world around them and gradually become more and more independent, more able to do things for themselves. Teenage years then can be a little bit tricky with lots of new hormones swishing around at this age to make your body ready for adulthood. And eventually, once we become an adult, our bodies stop growing, but they can carry on changing in different ways for the rest of our lives. We continue to age and may decide to have children as well. And that cycle starts again. Older people may have wrinkles, their hair may turn grey or white as they get older. Perhaps they might even need help walking, hearing, seeing, and eventually their cycle will come to an end. Just like humans, stars change and age over a cycle of their existence. So before I talk to you about the different parts of a star cycle, try and do the same thing again. If you use the Atomic Science Star Cycle resource, can you put those pictures in an order of what you think the star's life cycle might be? How do you think a star starts and changes, and maybe how it ends as well? If you've got some people around you that you can work with and share your ideas, that might be interesting too, to see what you think. Again, it might be a good idea to pause the video, do that, and then come back so I don't give you the answers before you've had a chance to do it. Now, it was a bit of a trick question because there are actually two different ways a star can go. There are two slightly different life cycles for a star. So if you put them all in one line, it's a bit of a trick question, I'm afraid. The sun at the centre of our solar system is what we would call an average star. What that means is that it's a normal kind of size. There are others that are much bigger and they do something slightly different. Now, all stars start as a stellar nebula. A nebula is a huge cloud of dust and gas in space, hydrogen, helium, things like that. And gravity pulls that cloud together and clusters of it bunch up, and eventually the gravity is so strong that it squishes together and makes its own star. The middle of it starts to heat up and eventually explode, and the star bursts into life, burning away just like our sun. Average stars get slowly brighter through their life. During the main sequence of the life, the forces inside and outside the star are pretty balanced and they remain fairly stable. So our sun is about 4.5 billion years old, and it's about halfway through its life cycle. Now, in a few billion years, as that fuel starts to run out, the rate of the crashing and reaction starts to slow down. Average stars go into a phase called a red giant. The centre of the star cools down and the outside heats up in the expanding process. The outer parts of the star then start to drift away in a cloud of dust called a planetary nebula, and the hot core, the middle of the star, cools and becomes a white dwarf when the remaining heat is lost through radiation and the star ends its cycle. On the other hand, there are also massive stars. And they're called massive stars because they literally have lots of mass. So they are massive. Kind of makes sense, doesn't it? These are loads bigger than the sun. And because of it, they burn hotter and quicker. They still start as a nebula, but they'll burn for less time than an average star. And then when that fuel starts to run out, it becomes a red supergiant. At the end of that phase, the star explodes in a supernova. After the supernova, a massive star can end its cycle in one of two ways, and these are both really interesting. Either the star collapses down and squeezes itself smaller and becomes very, very dense. The gravity collapses the little atoms that make the star, and one little bit of that star, the size of a pea, would weigh 100 million tons. Imagine a pea that weighs 100 million tons. That's called a neutron star. The other thing that might happen is a black hole. And with a black hole, gravity is so strong in the star that not even light can escape. And the star becomes its own black hole. It gets sucked into this black hole where all of the light can't escape. And there's all sorts of really interesting science and ideas and also science fiction about what happens in black holes. So if we live for long enough, if our human life cycle was long enough, we would actually see our star, the sun, change over time, because it does change. And we're still learning about stars and their life cycles. Over Christmas in 2024, a NASA spaceship travelled closer to the sun than any spaceship has gone before, only a couple of million miles away, which sounds like a long way, but that's really, really close. And there's going to be more information and data about what that spaceship learnt on its close little flyby right on the edge of the sun. And we can't wait for more information to come to light. To light. Ha! Get it? Oh, okay, sorry. It's amazing to think that when we look up at the stars, we're actually looking back in time in a way, because those stars are so far away that it takes the light a really, really long time to reach us. So the light that's hitting our eyes actually left that star thousands of years ago. Even the light that hits our eyes from the sun left the sun almost 10 minutes earlier, because it's such a long way away from us. So in a way, we're almost looking at the past. Now, because of the development of telescopes and technology, we're able to see really far into space. And the furthest away galaxy that we can see is called HD1, it's not a very fun name, which is almost 13.5 billion light years away, which means this galaxy was formed just after the Big Bang in the very early stages of the whole universe's existence. Pretty amazing. So if you haven't done that sorting activity, maybe you could give it a try. Think about comparing the life cycles of humans and stars and how they change through their lives. You could research the different phases of stars, learn more about black holes or nebula or neutron stars. Another good activity that you can do is you can play a big game of dot to dot in the sky, where we join some stars together to make a picture in what we call a constellation. There's all sorts of fun things that we can do to learn about stars and how they change over time. So I hope you enjoy that activity to do with stars' life cycles. Stay curious.